hand dryers, recycled polyester yarn, and fleece. Carbon fiber car parts, such as bumpers and spoilers, are nearly as strong as steel ones, and yet they're 1/5 the weight. Of course, a car that weighs less accelerates more quickly and burns less gas. So carbon fiber offers style that actually does go that extra mile. Custom spoilers, bumpers, and other parts make a vehicle more aerodynamic. When the parts are made of carbon fiber, they create this effect without the hindrance of extra weight. It's easy to get carried away with all the extras. Yes, that is a miniature basketball court in the trunk of this car. Carbon fiber parts are made of fabric that's tightly woven with very fine threads of virtually pure carbon. To transform the material into a rigid car part, they begin with paste wax. They brush it into the crevices of a fiberglass mold. This mold is for a car rocker panel. The wax seals the mold and also serves as a non-stick coating. They protect the lip of the mold with masking tape. Then they spray a second non-stick substance, polyvinyl alcohol, into the fiberglass form. Now they're ready for the carbon fiber material. They unroll it and spray it with adhesive. Despite the non-stick coatings, they'll want this fabric to stick to the mold for a while. The glue will gradually dissolve into the material. They press the glued carbon fiber material onto the lip of the mold. After all, they don't want any wrinkles in this job. This material has yet to gain its steely strength, so they easily trim the excess. They layer the fabric 7 times, again following the lines of the mold. They apply a permeable material called flow media to the carbon fiber layers. They place plastic mesh on top of the flow media and tuck it into the curves of the mold. They frame the layers with double-sided tape, which sticks because this area was taped off earlier to protect it from the non-stick spray. This strong double-sided tape is called butyl tape. They drape a plastic bag over the mold and press the edges to the butyl tape for an airtight seal. They pleat the bag and close the pleat with more tape. The pleats give the plastic bag some slack. They push the folds into every crevice of the mold, then turn on a vacuum. As the vacuum sucks the air out, the bag compresses the layers in the mold. Meanwhile, they activate some plastic resin with a chemical catalyst. They place a hose in the resin. The other end is attached to the vacuum bag. As the vacuum continues to draw air out of the bag, it pulls the resin into it. The resin saturates the 7 layers of carbon fiber to laminate them into the shape of the car part. After the part cures, it's ready to come out of the mold. Cleaning it up reveals the solid union of epoxy resin and layers of carbon fiber fabric. Carbon fiber can be molded into almost any vehicle accessory. Its versatility is one of its strengths. Painted to match the vehicle, the parts blend with the steel, adding some aerodynamic flash to this road show. Public washrooms often have electric hand dryers. Many prefer them over paper towel dispensers for environmental reasons, no trees killed, and no waste. Hand dryers also require less maintenance because there's no garbage bin to empty and no need to restock the machine with clean paper towels. This new generation model dries hands in 10 seconds and uses 80% less energy than conventional hand dryers. A sensor turns the unit on and off automatically. A circuit board with a microprocessor runs everything. The assembler builds a strip of 8 control boards at a time. They go into a track that first runs through a chemical cleaning. This preps them for soldering. The boards then float through molten solder. As the solder cools and solidifies, it fuses the components in place. An inspector scrutinizes every board, then, wherever necessary, does soldering touch-ups by hand. Finally, they separate the 8 control boards. Working a board at a time now, they plug in and test an infrared sensor. The sensor shoots a continuous beam to the area below the air outlet. The testing machine uses a strip of metal to represent hands. When the strip cuts the beam, it triggers the dryer to start. When it departs, the beam is restored, triggering the dryer to stop. To produce the airflow, a motor spins a blower wheel at a rate of 20,000 revolutions per minute. After connecting the blower and motor, they slip them into the unit's plastic inner housing. They add a rubber gasket to lessen vibration noise, then close up the housing. Next comes this electrical heating element. Its coils will heat the air as it passes. After applying mandatory electrical warning stickers, they install the circuit board on a mounting bracket, then connect the bracket to the housing. Then they connect the wires coming from the heating element and the motor to the control board. Now they send the unit to the testing area for quite literally a dry run. They make sure it turns on and off properly. They check the blowing force, the air temperature, the voltage. Elsewhere in the factory, they work on the hand dryer's outer housing. It's cast from zinc. After it comes out of the mold, they polish it with a buffing wheel to prep the surface for painting or chrome plating. In the plating tank, they run a positive electrical charge to chunks of metal and a negative charge to the zinc cover. This draws metal particles through the water like a magnet onto the surface of the cover in a thorough and even layer. For this model, they first plate the cover in copper, then nickel, then chrome. The underlay metals are required for the chrome to adhere. Once the plating's done, they clean the cover. Apply an arrow sticker pointing to the air outlet. Then glue on a plate with the name of the manufacturer and model. The inside unit attached to a wall plate now fits right inside. They fasten the cover using tamper-proof screws, then shine it up with a few squirts of window cleaner. These hand dryers come in a wide range of finishes, letting you dry your hands in style. The recycling of plastic bottles is changing the fabric of society because those bottles are being turned into polyester yarn. The recycled polyester yarn is woven into material that's used to make socks, fleeces, and other things. It puts a whole new spin on polyester. Polyester is made from oil, so recycling means we get more mileage from a precious resource. They convert polyester manufacturing waste on the left and plastic bottles into chip form. Pulses of hot air toss the chips, giving them hard shells. They go through a dryer to get rid of moisture that would weaken the final product. The shells keep them from sticking together, aiding the drying process. A worm screw moves the chips through heated pipes, which melt them into a thick liquid. This molten recycled polyester is now ready to be turned into yarn. It will be pressed through this die plate that looks a lot like a shower head. It's part of a device called the spin pack, which also includes a mesh filter, a metal distribution plate, and bits of shattered metal for extra filtration. It's important to screen out impurities that might compromise the recycled product. They screw the cap onto the spin pack and insert a metal connector piece. They preheat the pack so the polyester won't harden as it flows through it. Then they transfer it to one of the openings from which the liquid polyester flows. There are dozens of these openings, all capped by a spin pack. "68 tiny holes in each disc shape the recycled polyester into filaments. They cool and harden as they exit. Each one is 5 times finer than a single human hair. Some of it breaks during equipment stops and starts, and that goes into a big box to be recycled again. The rest converges and funnels into a guide, which bundles all the strands into one yarn. The yarn travels around rollers into a compartment where air buffets the yarn to entangle the filaments. This holds them together. A spool then racks up the yarn at a speed of 125 miles per hour. Next, an autonomous vehicle pulls up. The spools move into position, and a long spindle emerges from the automated vehicle to collect them for more processing. They group a sample from every production run with strands of black yarn, which allows the lighter yarn to stand out. They fray both ends of the yarns with a razor, so they'll be easier to examine under a microscope. The technician projects the magnified image onto a screen and counts the number of filaments. At this point, the yarn is stiff like dental floss, but that's about to change. This machinery pulls the polyester yarn over heated rubber rollers. The process stretches it and realigns the molecules. More equipment twists it, and then it's taken up by automated spools. Now, this recycled polyester yarn is less like dental floss and more like wool. From plastic bottles and manufacturing waste to polyester yarn. This transformation has taken just a couple of weeks. This recycled yarn is now ready for the material world, making consumerism a less wasteful thing. The invention of polyester fleece in the 1980s changed the way we dress for the cold. Instead of heavy and constricting clothing, we can now layer with lightweight fleece. Its texture gives us that warm, fuzzy feeling, and so does the philosophy behind it, because it's often woven with recycled yarn. From trash to textile, today's fleece offers warmth from waste, because it's partly knit with yarn made from soda bottles and other discarded plastic. The recycled yarn looks and feels exactly the same as the virgin kind. They both unwind into a huge circular knitting machine. It knits a lot faster than Grandma, so we've slowed down the video to give you a good look at the knitting action. Hundreds of tiny needles grab and stitch the recycled and virgin yarns together to create a perpetual tube of material. This machine generates 3 feet of polyester every 2 minutes. Big metal brackets flatten the knitted tube so it can be taken up by a spool. Inspectors check for any major flaws. If necessary, they'll halt production until the problem can be fixed. Then it's over to the laundry department, where a cylindrical machine washes and dries the material. It then dyes the fabric under pressure and adds a water repellent chemical to the fabric. After another wash and dry, equipment funnels the polyester into a holding bin. They feed the long polyester tubing through a device that twists it to wring out the rest of the water. As the knitted tube exits the twister, a circular cutter slits it, turning it into a sheet. This sheet of fabric is thin and not fleecy at all at this point. One side is a smooth knit, while the other is rougher. It has thousands of tiny loops. Cylindrical wire brushes will transform this polyester into fleece in a process called napping. Each brush spins at a different speed. It's all carefully calculated to break the knitted loops without tearing the fabric. The nap side of the material is now fuzzy and fleecy. The smooth side of the fabric winds around a second set of spinning brushes. They pull fibers through from the fleecy side to evenly distribute them on both sides. The double brushing increases the fabric's thickness 5-fold and builds air pockets into the fleecy pile for insulation. All this without adding weight. A spiraling blade then shears the fibers to a uniform length to prevent pilling, which looks bad and can compromise those insulating air pockets. Each production run undergoes a battery of tests, like this one for water repellents. If the water doesn't soak into the fleece, it's a pass. In another test, they insert scratchy nylon strips in the head of the tool. As it spins, it rubs the fabric the wrong way. The test simulates wear and tear and determines whether the fleece will resist pilling. They try to set fire to a swatch that has flame-resistant fibers woven into it. The fleece smolders and then extinguishes the flame. Once the fleece has passed all the tests, production resumes. Grippers pull it along the edges to stretch it to the desired width. Steam rises to heat set the fabric to its new measurement. And now this batch of fleece is ready to sew. They fold it for transport to the clothing factory. In its various colors and textures, this high-tech fabric will help protect you against the forces of nature. And with its recycled content, it also gives nature a bit of a break.